Hi everyone, welcome to the Postgraduate Diploma in Design, and specifically this is Materials Technology. My name is William. My details are there. You can email me or pop in at any time uh, to engage Materials Technology. The first module is in line with the subject guide which you have on Blackboard, where the first part of the content is the introduction to structure, classification, and processing of materials. So that's why it is the introduction to materials and production techniques. So just a bit of introduction as you would imagine or would know already. Materials technology is a discipline that deals with materials and the production techniques, either to design, produce, and optimize existing products or to develop new ones. And the challenge we are faced with is generally the sustainability and securing our future, which is the future focused design practices. And it is important to consider the cost implications of materials and the production techniques, and consider sustainability as well. This is the plan. We first defining the scope, the subject and a scope, and then ideally identify the needs or problems, because when we're thinking interdisciplinary, because we're coming from different design backgrounds, we will have specific requirements of materials. So I would advise that you have that in mind throughout the materials technology subject. Think interdisciplinary and think in your specific discipline what you would ideally require materials for, what are the specific requirements of materials and processes, and then we'll focus on applications. Expand it a bit more. Module 1 runs similar to module 2, and then module 3 would be the block in person. The important thing to consider here is every time, each day, it is as advisable that you guys get together as a peer-to-peer discussion on whatever we would have done in class or you would have done as a self-study. Get together with someone in class as a peer-to-peer, just to keep in check and just to see if you are on the right track or see what the other person is doing, because the key thing again is interdisciplinary. So it's not going to be the same, the things that we require, as you would expect. So it's important to have these discussions afterwards. So we would only meet twice in a week, which will be on a Monday or a Friday. The rest of the days will be self-study and consultations, which you would need to get in touch with me if you need to consult on anything that we would be having, anything that will be running at that time. First, we introduce a topic, and then on a Friday, it's usually presentations. But depending on public holidays, this might change slightly, but it will be communicated accordingly. Module 3 will be similar. It's just that extra hours because it's face-to-face. Again, we will have Mondays where we concentrate on introducing certain topics and concepts, and then there will be self-studies still in person, me being around and you guys engaging in whatever we will be having at hand, and then some consultations as well and presentations. So it will still be a similar approach, but just in person. And afterwards, again, you would be given time to have to apply what we would have introduced and spoken about. And these are the actual dates that we will be doing these different tasks. This gives a general idea of the outcomes or the deliverables, the things that I'm going to ask of you from the content that we would have covered. It might not necessarily be all of them, but some of them. The first one being the analysis of articles, which you have. So the idea is we are trying to match materials and technologies to the design requirements. And first, we need to understand the market need, thinking interdisciplinary, because we come from different design disciplines, and then understanding the market need means it's usually driven by the design requirements. Hence, the design requirements is very important. Then you get to critical concept analysis, where you arrive at variable concepts based on what you're trying to do. The embodiment means selecting working principles or deciding on the sizes of the whatever you're trying to do, the layout, and then you evaluate and the initial estimates of performances and costs. So this can be different depending on the discipline. And then the detailed design is also called the technical analysis, where now you do the full analysis of the critical components of what you're trying to do, the preparation of detailed production drawings, showing dimensions, and specifying the precisions, tolerances, identifying materials and the manufacturing path. So the idea is, because we're thinking interdisciplinary, we need to allow ideas from various perspectives and insights to percolate within the team. That's why you have to engage afterwards in the peer-to-peer. So we need to create, in that way, we're creating a culture of a shared ownership in a way, and the objective of materials technology is we need to recognize the impact that materials and the technology have on our world today, and make informed decisions regarding the material selection using a list of requirements. Again, the list of requirements comes into play because it depends on what you're trying to do or what you need materials for, and synthesize the key concepts, because when you think of materials, it is not necessarily the material that you're looking for. It is what the material offers, which is the property attributes. So not all of them are necessary. Hence, you need to synthesize the key concepts and the key aspects into a coherent, structured material selection. So you will choose the material based on the property attributes which materials can offer. That will inform the future design direction. So in general, you will bump into design factors depending on your discipline. You need your design to do a specific function or to have a purpose. and you need to have a specific context. Depending, or maybe in all the disciplines, we're hoping for our designs to be human-centered. We're looking for creativity and innovation, and we're looking for visual, tactile, and aesthetics. We're looking for sustainability. We need to consider costs. We need to consider the legal responsibilities because they restrict us on what we can do. That has to be considered as well. Materials technology. So we need to consider materials because, for instance, for the purpose of the function, you can have materials that will help you meet specific functions or purpose, hence the material selection and the processes as well to achieve certain purposes or function or context. There are certain processes that work best or better than the other to achieve what you're trying to do. So coming to the context of this subject guide as introducing the materials and the processes or processing techniques. If you can think where you are now and look around, what materials do you see? So, and then bear in mind that materials are substances out of which things are made of. So you can realize or you can see how broad materials can be. And throughout history, we have materials, new materials being grown or new materials being designed or being manufactured, and they change how processes, and that affects the processes. Processes have to change to best suit the new materials that come into being. So the materials, the technology, and the science, they are interlinked and they influence each other. Hence the technology advancements, the science advancement, and materials themselves, the advancement of that. So all this are interlinked because they influence each other throughout history. That's what's been happening. You have new materials, you can't process them the same way as you used to process the previous ones. And then people, the scientists in the laboratories, they creating or generating new materials that influences the new technologies and so on. So to understand materials, we first need to understand certain things. The first thing that we need to consider is the structure, and which can be considered in terms of atomic and microscopic or macroscopic structure. So we need to understand structure if we want to understand materials. Materials do what they need to do because of one, structure. Again, because of the properties and processing. So how you process the materials influences the functionality of the material. As you can see in the diagram here, processing will influence both the structure and the properties. So in summary, all we are trying to do is to use the right material for the right job. And we need to understand the relationship between the properties, structure, and processing because they influence each other. And we need to recognize new design opportunities offered by materials and select the appropriate ones. So to understand the classification, we can go backwards to say materials, they form parts of material science and engineering, and we have different materials that are suitable for engineering, for the physicists, for the biologists, for the chemists, and for you guys as designers, which will be product design, engineering design, architecture, graphic design, and so on and so forth will be here. Then you are likely in your discipline to deal with some of these materials, if not all. The important thing is the classification of materials does not change. What changes or what is different is the application in different disciplines. So we need to know and understand the distinguishing characteristics of the different materials so that we know how applicable they are in our different disciplines. For instance, ceramics, you can think of them in terms of the traditional ceramics, which would be the earthenware, the porcelain, and the stoneware. Or you can think of ceramics in terms of the advanced ceramics or the modern ones, which would be this ones here, the aluminous silicon carbides or silicon nitrides or zirconias. So this one would be the typical that you find in space shuttle, those kind of ceramics. And for instance, polymers will always be polymers and classified as either thermoset, thermoplastics, and that doesn't change. But what changes is the applicability of these classes to the different disciplines, which is for you guys to try and figure out. But generally, this is the classification of materials. And for fashion, it will be either organic or the natural materials. Again, for fashion, it would be the synthetic materials as well. So they will be here somewhere. We just need to think interdisciplinary in terms of the classification and in terms of the distinguishing characteristics of these materials to understand them so we can choose the best one for what we're trying to do in our different design disciplines. So then in terms of manufacturing, because now we've covered the second part, which is the classification, now we go into the processing techniques. So from the Latin word manufactus, meaning made by hand, manufacturing being the process of converting raw materials into products, which links up very well to materials technology by definition, meaning the discipline that deals with converting raw materials using different processing techniques into functional goods. So as designers, why do you think it's important to study manufacturing processes? Manufacturing process starts with design first. Then after design, you select the appropriate materials for what your designs are. Then you need to select the appropriate method of producing your design. That is, these three things are important. These three things are important in the manufacturing part of the materials technology. It's not necessarily focusing on the manufacturing, but it links up to you guys as designers in terms of you need to design, you need to select the materials, the appropriate ones for your designs, and you need to select the appropriate production techniques for what you're trying to do, because some of them are more suitable than the others. For instance, you can think of this in the context of your own discipline, but I use this to illustrate the point. choose the right material or the right processes, not material, there is a hierarchy that you can use. And the important thing here is when we get to the block week, this will be something that will be a typical outcome to show your process work and what informed your choice of processing techniques, what informed your choice of materials. So you have a database because you don't necessarily care about the manufacturing, but you need to know about manufacturing. You can go to the database and figure out what is the database of the processing techniques at my disposal. Depending on what you're trying to do, if you want to join or shape, or you want to do a surface treatment on whatever you're trying to do, then you can make a choice within those processes. If it's shaping can again be broken down into different types of process. The aim is to choose the best one. Then you go shaping. What are the shaping methods? Casting, deformation, molding, composite, using powder shaping techniques, or rapid prototyping. Which one is best? If you think it's molding, what are the different ways you can mold? Compression, then you would need to know the types of materials that work best for compression processing techniques, or rotational molding, or injection, and so on and so forth. If it's injection, what are the typical costs associated with this? What are the tolerances that I can achieve with that? What are the specific shapes, the intricacies of what I'm trying to do? So this has to translate in your choice of processes or choice of materials stepwise to show that you covered all angles. So you can talk about this, and this is the kind of thing that I would look for in like a technical report when you're talking about materials and processes. What have you considered? If you're thinking it's joining, there are again different ways you can join: adhesives, welding, fasteners. If it's welding are you looking for brazing, soldering, gas, ultrasonic friction? Where is it suitable? What are you trying to do, and what scale are you trying to do it? And thinking sustainability as well as you go along. Then if it's gas, what are the different sizes you can work with? What is the different thickness? The cost again, and what geometries can you get out of the process? So again, a stepwise way of selecting the processes. If it's surface treatment, different ways you can do surface treatment. Coating, if it's the best one, or polishing, or heat treatment, and so on and so forth. And what is the best way? The aim is, what is the best way to help you produce what you're trying to do as a processing technique, because we're dealing with materials and how you work with materials such that they do not negatively affect what materials offer, and such that you choose the best process that minimizes costs for you while not compromising quality. So this is just a summary of what we just spoke about for you guys to just read at your leisure. Then material selection. There are different ways you can choose the best materials for what you're trying to do. The choice is based on the application and the required material properties and the budget. Properties which is the property attributes, which is what you're interested in, not necessarily the material, but we always look at it as material, but it's actually the properties that the material can give you, which would be either the mechanical properties, the physical, the thermal, the electromagnetic, the chemical. That is what gives you purpose or the function in terms of what you want to do. It can be visual, architectural, product, fashion. It needs to serve a specific function, that there are specific materials that will help you or that will interact with each other to help you achieve that. It's just the repetition of properties, your consideration for properties, to highlight or emphasize that you are interested in property attributes and not necessarily the material. And then again, thinking interdisciplinary, what does this mean in my own design discipline in terms of materials? What do I use materials for? What do I want them to do? I'm just skipping through this quickly because they are self-explanatory in a way, and you can read them in your own time. Then generally, when you're selecting materials, the steps might be different slightly, but generally, as we've been mentioning, you have to consider the requirements. What are you trying to do? Decide on the requirements of your application. Second step, what are the possible materials that you have in your disposal to achieve your design requirements? So deciding on possible materials that can be used in the application. Having the possible materials, then decide on what changes in the material properties are needed, if anything. If you need to change that, because how you process material, like how we saw that interlinking, the influence between the structure, the properties, and the process, they influence each other. So you need to consider that as well. The final step, deciding on which material out of the possible ones that you have is best or fulfills the requirements, fulfills step one, because more than one might, but there will be a better one. So if you follow this step, it will help you narrow your selection. A different way of doing that, and this one shows a combination of material selection and process selection. So you start first with prospective materials and processes. Out of that, you screen them down based on the functionality or manufacturability. So these are the materials that I have. How am I going to process this such that they don't negatively influence the property attributes that the material gives me, and still get the functions that I need to get out of that? Then if you come to the correct ones or the prospective ones, then those that are rejected will be the ones that do not meet the functionality that you're looking for and the manufacturability. There's no processing technique that you can use for what you're trying to do. Then you only continue with the feasible materials and processes. Then you screen again by relative performance. This is done by rating, and there are different ways you can do so. We will talk about this in the blog week. I will introduce the ways you can rate the materials and performances. Then eventually you come out with the best materials and processes. Again, a stepwise way of choosing materials and processes. Cost, as mentioned, very important. And then in terms of materials and processing techniques, cost is referring to the cost of material itself and the cost of the processing. That gives you the total costs. We're trying to minimize the cost. And this just gives you a distinction between cost, price, and value. What we're trying to do is to minimize or to maximize value and minimize cost. That way, we have profits being maximized. We achieve this by minimizing the material and the manufacturing cost without compromising quality.